In Chapter 5, we want to primarily focus on nomenclature, meaning naming these different compounds. For example, let me just sort of quickly name these two. So H2O, you may already know this is called water, and that is an acceptable name for that compound. Now, for this one, well, it has a little bit more of a chemical looking name. So the first element is magnesium, and then this NO3 group, that is referred to as a polyatomic ion. And we're going to see that in a few videos from now. It's known as nitrate. Okay, so when I name this one, it's going to be magnesium nitrate. The details of naming this, we'll see later. Okay, I just sort of wanted to get a couple names out of the way. This page, this slide, let's focus on now the chemical symbols that we see here, the chemical formula. Now, obviously, the letters in a formula are telling us what the elements are. Okay, in this case, hydrogen and oxygen. And then the subscript is telling us how many of, in this case, each hydrogen we're looking at. Now, if a subscript is missing, then you assume that there's a 1 sitting there, so there's 1 oxygen there. And just to come full circle on this, if I was to draw this molecule, it would look something like this. Oxygen in the middle there. These little dots are lone electron pairs. These lines are covalent bonds. And then we see the 1 oxygen and 2 hydrogens. Now, we are not going to draw molecules in this chapter. Drawing molecules comes in at chapter 10. Okay? So again, just sort of, I wanted to complete the story about this molecule here. Now, magnesium nitrate, a little bit different picture here. So it's a little bit more busy. Obviously, we still have the element symbols here. So yes, magnesium, nitrogen, and oxygen. So these are true, okay? But again, like I was saying, when you see this particular cluster of 1 nitrogen, 3 oxygen, that is known as the nitrate ion, and it has that particular formula. Again, in a few videos, we'll look at that in more detail. And since they are coming together in this particular pattern, that's why I'm naming it nitrate and not something like magnesium nitrogen oxide or something like that. Mg1, magnesium, 1 atom. Kind of similar to what we just saw a second ago. Let's take apart this a little bit more though. So notice and actually let me just rewrite this portion. And we'll throw magnesium here just to make it look right. Now, what we have to focus in on here is the fact that we have a set of parentheses that we're dealing with here. Sort of in mathematics, parentheses sets one part of the formula off from the other part. Well, that's basically what's happening here. Whatever is within the parentheses, you look outside the parentheses to see how many of each of those are present. So, for example, in this one, what it tells me is that I have 2 of these nitrates. And notice I'm carrying the -1 charge because this particular combination of atoms does produce a single negative charge overall. And by the way, that just happens to balance out with a magnesium +2 charge. Something similar to what we saw back in chapter 4, working with ionic formulas. But let's go a little further here. Okay, so again, I got 2 nitrates. Well, now notice what this is telling me. If I want to total up the number of atoms, I'm really talking about 2 nitrogen atoms and 6 oxygen atoms. So again, whenever we have this 2, we basically distribute it within the parentheses like that. The last thing I want to say about these 2 molecules is that they are what's called the empirical formula and the molecular formulas for water and magnesium nitrate. Empirical formula is the simplest ratio of atoms. For example, 2:1 is as simple as you can get for water here. Same thing can be said here. The simplest ratio between magnesium, nitrogen, and oxygen that's possible for this compound So 1 magnesium, 2 nitrogens, 6 oxygens. I can't simplify that ratio any better than that. Again, it was 1 magnesium to 2 nitrogens to 6 oxygens. And as it turns out, again, for both of these molecules, the formula represents the molecular formula as well. And that's the atoms in the chemical structure. We can see it best, I think, with water. It's simpler. Water looks like this. Like I said, 1 oxygen here in the middle, 2 hydrogens coming off of it. That is the molecule. That H2O here matches up with the molecule. Okay? So again, in this case, both of these formulas just happen to be the empirical formula and the molecular formula for each of these compounds. In the next video, we'll expand on that and talk more about the 2 different types of formulas, okay?